Hi, my name is Sebastian Løske and I'm from Aarhus University. I'll present our paper Text-Driven Stylization of Video Objects in collaboration with Serge and Sagi from University of Copenhagen. Editing and stylizing videos using human instruction often requires both domain expertise as well as unintuitive and complicated software. We seek to eliminate these requirements by specifying an edit or stylization through an intuitive and semantic user instruction in the form of a text prompt. Our method takes as input a video, an object in a video, and a target text prompt. The result is a video where the object is stylized according to the text. For example, given a video of a black swan swimming in a lake, we produce matching stylizations according to a given text. These stylizations are applied to the video object in a temporally consistent manner. With text, one can express complex and abstract stylizations without requiring any manual editing skills. Our method generates natural and consistent stylizations of objects for a diverse set of videos and target texts. Importantly, our method is zero-shot and does not require a pre-trained generator. Our method only requires an input video and target text. To apply temporally consistent edits to an object in a video, our method uses the atlas decomposition method presented in the paper Neural Layered Atlases. NLA decompose a video into a set of layered 2D atlases. Each atlas provides a unified image representation of an object or background over the video. The video can then be reconstructed from the predicted 2D atlases. Also, edits applied to the atlas representation are automatically mapped back to the video in a temporally consistent manner. However, editing an atlas still requires manual editing skills from the user. NLA trained their model to reconstruct the input using this intermediate atlas representation. We instead want to specify edits via text and use the NLA method to apply these edits in a temporally consistent manner. With this purpose, we first train using the NLA method for reconstruction and then minimize a set of objectives that aim at matching the style of the foreground object with that of a target text. To train our model to stylize the foreground object, we first uniformly at random sample a set of frames from the input video and pass them to the stylization model. This gives us a set of stylized frames. From the stylized frames, we do a view sampling procedure that generates both local and global views of the object we are stylizing. We then compute a loss function that takes as input the sample stylized views as well as the local and global target text given by the user as input. Our loss objective includes a local loss. The local loss computes a semantic loss, which is the cosine similarity between local views and a local target text. Both the local text and views are embedded with the contrastive language image pre-training model, also referenced as CLIP. The local target text then contains local specific semantics, such as rough cactus skin, and the sample views contain a more zoomed in and detailed view of the object we're stylizing. Hereby, the local loss can focus on texture and fine-grained details of the stylization. Our loss objective includes a global loss. The global loss computes a semantic loss between views that include the entire object and a global target text. The global target text includes words that describe the global context of the object we're stylizing, for instance, a swan with cactus skin. The intended goal is that the global loss will preserve the overall context and the global semantics. Here we see an example of the effects of each of our loss terms. In the first example, we see that all losses combined result in a natural stylization that shows clear characteristics of a swan with crocodile skin. Without the local loss, the results lack fine-grained details, and without the global loss, the global semantics are less clear. We demonstrate that varying the specificity of the target text prompt affects the level of detail in the stylization. For instance, here we have a boat made of wood, and by adding boat made of dark walnut wood, or even fishing boat made of wood planks, we see that it creates different stylizations and adds more detail when the texts are more specific. We add neutral prefixes to both the local and global target texts. A neutral prefix text is, for instance, a photo of a, and then the target text, which in this example is a dog with Bengal tiger fur. We demonstrate that adding prefixes increases the robustness and quality of the results. And Also, that varying the number of prefixes to sample from in each training iteration gives us more detailed results. To conclude, we developed an intuitive and semantic control for stylizing objects in videos using text. And our method is able to generate consistent style changes over time. We stylize objects in videos by using both a local target text to control the fine-grained details and a global target text to control the global semantics of the stylization. We demonstrated that the specificity and the prefixes of the target text can have a significant impact on the details produced by our method stylization. For future work, it would be interesting to extend our model to be able to generate shape changes or even new objects from scratch. Visit our project website for more results and details. Thank you for listening.